आदि स्टार्ट करें।
Can anyone tell me if I'm audible without any background noise?
Assalamualaikum ji bhai, you are audible.
Thank you.
Assalamu alaikum. My name is Hadirao. I'm Joint Secretary Medical Aid Society. Today I'm here to welcome you all on the first ever Meditech Resonance Conference on the theme of reviving healthcare with medicine, public health and AI. Today we are gathered here for the second pre-conference workshop that will be delivered by Dr. Faizan Shehzad. Dr. Faizan Shehzad is a final year medical student at Rawalpindi Medical University. He has more than 10 publications across national and international journals. Moreover, he has also been invited as a speaker to different undergraduate workshops, both on campus and online. He has presented researches across national and international platforms and have won many awards. Today, he has been invited to this workshop to deconstruct the science behind data analysis. Dr. Faizan, you may continue with the presentation.
Thank you so much for your kind introduction. And I would first of all like to say that everyone, the presentation and the data sheet has been shared with you. So if it's possible, I would highly recommend that you open up your laptops and you attend the meeting on your laptop so that you can perform the analysis. You can perform the analysis along with me. That way you will be able to learn it much better. And for example, if you're on mobile, it's okay. Then just take the webinar and perform it after the presentation is done. Now, would anyone mind telling me if my screen is visible without any lag?
Yes, sir, your screen is visible.
Okay, that's good. Anyways, let's start with the presentation. So data analysis deconstructed. Data analysis is, in my opinion, the most important part of any research. And I think many professors would also say the same thing. The reason we say this is because the research in a research, what you're essentially doing is you're taking in information from the patients, which is known as data. Sorry, you're taking data from the patients, which does not make any sense to the normal people. And then you're going to perform an analysis on it and you're going to draw conclusions and you're going to make sense from it. And then you're going to present that one final sense or that one final conclusion to all of the people in the world, to worldwide online. And the people, clinicians and the doctors who are interested in this field and who are part of the practice of this field, they're not going to see the whole analysis and whatever you did. They're going to see the conclusion that you draw. And the main thing is that a conclusion should be robust, and for that you would need the data analysis to be robust as well. I'm going to start with the two types of data. There's quantitative and then the qualitative. Qualitative data is your gender, male, female, or intersex, or depending on how you identify your religion. It's basically the data without any numbers. Whereas the quantitative data, it means the data which has numbers, such as your age. I am 21 and a half years old. Haris would be probably 21 as well. So then he, like, this is our quantitative data. My height is 5'7", so that's the quantitative data of height. Weight, so someone weighs 80 kilos, someone weighs 70 kilos. So you see, that's the main difference between both of these. Then the categorical data is now further divided into two types, nominal and ordinal. Now you're going to say that the numbers are in ordinal data, so it should not be a part of categorical or qualitative data. But the thing is, that you can also write first as this. You can also write it as FIRST, like this. You can also write second as SECOND. So you see, in this way, ordinal data is actually a part of qualitative data because it's not a numerical cheese. It's just that first, second, and third are certain qualities of a person who got specific position. In the nominal data, that's like male, female, or our names, patient ID, etc. Now, the second type of data, numerical data, is further divided into discrete and continuous. The discrete data is the data that cannot be divided into decimals or that cannot be divided into more further smaller things, such as the sample size of 100 people or 200 people or 400 people. You cannot decrease it to, let's say that we included only 250.5 people. You can't like divide a person in half and choose him as your sample. That's the main difference in discrete and continuous data. In continuous data, for example, if a person is 5'7" 7.3 inches tall, you can divide it more and more and more. For example, if their weight is 60.1 or 72.5 kilos, you can divide it. But discrete data cannot be divided. And so the test scores, for example, if you have 10 MCQs, you score 7 by 10, that's your marks. 7 by 10 or 15 by 20, that's your marks. You can't score 15.5 out of 20 on an MCQ based test. But if you have a SEQ based test, you can score between the decimals, right? Now, there's a difference between qualitative data and qualitative analysis. Qualitative analysis is known as descriptive analysis. It's performed which does not has any statistical test applied. For example, chi-square, t-test, there are no such tests in a qualitative data analysis. Whereas if you're analyzing data in quantitative side, just like this right here, you're gonna test and then you're gonna get the p-value. The p-value is gonna give you a certain conclusion. And obviously, since the p-value is gonna give you a conclusion, this means that your quantitative analysis is a better or more advanced option than a qualitative analysis. Personally, I would always recommend you to do research that involves quantitative data analysis because qualitative or descriptive data analysis is occurring in each and every research. But if you do advanced analysis, if you do these inferential statistics, it's gonna improve your study way more. Okay, so this is my personal recommendation to you. Now, back towards the qualitative data analysis, I have shared the file with you, and now I'm going to perform the descriptive analysis of this dog toys Excel sheet. Okay, I'm just going to open the Excel sheet right now and give you a sort of idea of the whole Excel sheet. This is a research which I found online, and it had data which was very clean and it was actually distributed in a very nice manner. So I chose this one for this webinar. This is a research on the dogs, their type, for example, their breed, their size, their favorite toy, and then the toy number of toys they have, and then how much days it takes for them for one toy to be destroyed by their mouth or by when they play. Uh, the toys owned is a is a क्या नाम है quantitative data, right? It's basically a numerical value of the number of toys that the certain dog has. Similarly, days to fail is also a numerical value. It's also the numerical value of the number of days it will take for that particular dog to destroy a toy. So both of these would come under the category of quantitative data and not the categorical data. Okay, or also known as numerical data. But the favorite toy, this is a nominal categorical variable. Similarly, dog breed is a nominal because there is no certain breed of dog that's going to be superior to the other one. But there are different distinctive breeds, right? And similarly, is the toy chosen. But when you're talking about a dog size, there are certain order to it. The small, medium, and large. Now, obviously, the large dog is going to be the largest one. So here we see that there is a whole order for the data, and now we're going to consider this as ordinal data, but it still comes under the umbrella of qualitative data. And now that the data has been described, I'm just going to open SPSS, and I recommend that you do it as well. and we're going to go to File, Import Data, Excel. We're going to click on this Excel sheet. We're going to click Open. And now we're going to click on each and everything. What this is basically going to do is that it's going to read the variable name from the first row of data. The first row is the variable name. Okay. Now, the other thing that it's going to do is it's going to tell that if a certain percentage, 95% of data is continuous, it's going to consider this as continuous. As you can see, there are different logos beside each data. I'm just going to explain them in a while. Then we're of course going to ignore the hidden rows and columns. And now this is remove the leading and trailing spaces. Let me tell you what is a trailing space. This right here, if I add space, this thing that I've highlighted right here is a trailing space. If you do not remove it, SPSS is gonna consider this as a whole separate variable, which is gonna make very big problems for you. So I always recommend that you remove these trailing spaces either in the data or from the SPSS. Similarly, the leading space, as you can see, this is the leading space in front of the fuzzy dog. So you can either remove it from the data like I'm doing right now, or you can remove it via SPSS. I recommend using SPSS because it will automatically do it. And we're just gonna import all of this. Now, as we can see that the data has been opened, we are first of all gonna change the measure or the type of data. As you can see, toys owned is a whole numerical data. Similarly, is the days to fail. So we're gonna go variable view. We're gonna click on it and we're gonna consider it scale. SPSS has a different name for numerical data. It calls it scale. Similarly, days to fail is scale. Then we're gonna go to data again, and we're gonna see dog size is medium, small, or large, which means it's ordinal data. We're gonna go to dog size, click on this, and click on ordinal. This is how we're gonna basically correct the input values of our data. Then, of course, you can change alignment to your own choice, but I don't do it because then again, it's not necessary. Similarly, the labels, putting in labels, people put in labels to describe the data, such as we can put in as number of toys owned. But I always name the variable in such a way that we can, always see what's inside the particular variable. Now, all of this has been imported, and I'm just gonna go back to my presentation and I'm gonna tell you about descriptive analysis. Now, for qualitative data, for categorical data, we will calculate the frequencies, and for the numerical data, we'll calculate the mean, median, and mode. Mode is not necessary. It's actually just used in very, very few researches. So we don't calculate it as a part of our, usual data analysis. But the main thing is the mean and the median. Okay. Now, what is the mean? Mean is the average of all values. For example, if we have this data set and we need to calculate what is the average of this data set, we're going to calculate the mean. Median is the middlemost value. So if you arrange the data from a minimum to a maximum, scale, what would be the middlemost value? That would be our median. And then mode would be the most common value. As you know, if you're having a data that's continuous, you're always going to have a chart. Let me show you. How. We will go to analyze, we'll go to descriptive statistics, and then we'll go to frequencies. This is how we're going to calculate the frequencies of each and every categorical data. We're just going to move all of these into the variables tab. We're going to click on statistics, and we're going to see that all of these are present here. But we're not going to click on each and any one of them. Why? Because the data we have is categorical. Okay. After clicking on charts, we're going to click on bar charts. Always make bar charts for categorical data and histograms for continuous data. Now, if you go to format, you just want to make sure that it's in ascending values and compare variables. That's it. You just don't need to do anything else. And then there is no option that you have to change in style or in the bootstrap. You're just gonna tick. If it's not ticked, you're gonna tick the display frequency tables and you're gonna click OK. Now, this is going to give you a whole frequency table. First of all, it's going to tell you that there are 50 entries in our data and none of them is missing. If there's a missing value, you'll have to skip it. Okay. Now we can see that there are no missing values, so we can proceed to the next tab. We can go to, first of all, the variable of the favorite toy. As you can see that chew toy was present in 8 people, so it's 16% common in our data. Chirpy bird is 22% common. Tennis ball is the most common one, which is 24%. So we will basically report in our data that tennis ball was the most common favorite toy chosen by the dogs. Now, as for the dog breed, we can see that the fuzzy dog was the most common breed which was present in our study, and it was present in 36% of the dogs. Okay, once again, all that you have to report is the most common value. Usually you have to report the most common values. But if your study questionnaire is small, or if you are just performing only the descriptive analysis, then you will always report the whole of the data. Moreover, we can also see that the size of the dog, medium, was the most common, and in the toy chosen, we can see that duck and hedgehog were the most common one, or were the fan favorites. This is the bar chart. Usually, I would recommend making charts in Excel, but if you want to make in the SPSS, it's up to you. But Excel has better options for making charts. If they some other there may be a webinar on Excel, I'll be sure to show you guys how to use Excel and do all these things in Excel. Now, these are all the graphs, and as you can see, these graphs are a bit, you know, I don't know, bulky, you can say, but personally, in my opinion, using words is the better option, or using Excel is a better option. But do not make graphs in, SPSS. So this is how you see the charts, or you see the description of the categorical data. Now I'm going to show you the description of numerical data, also known as the continuous data. We're going to go to explore, not frequencies. We're going to go to explore, and we're going to move both of our variables to the dependent list. We're going to go to statistics, and we're just going to see if the descriptives are tagged with 95% confidence interval. I'll show obviously what the confidence interval is in a bit, but first of all, let's just see how we do this. Now we're going to go to plots. We're going to click on stem and leaf. You can make this or not. It's actually a 50-50 controversial graph. It does not give any additional value. I just like the shape of it, so I always, click on it. Then histogram is important. It's very important. I always say, and I said this before, histogram for continuous, bar chart for categorical. Then we're going to click on normality. I will explain what normality is. You're going to click on continue. You're going to change nothing in the options, and you're not going to change anything in the bootstrap as well. Okay. You're going to click on OK. And it's going to give you the descriptives. Okay. This is the whole descriptives. Now I'm just going to first of all show you this is how a continuous variable is, shown. As you can see, this is how the continuous variables are shown. This is in a histogram. This is a histogram. This is our, you can see all of these bars that you can see are standing each other with each other shoulder to shoulder, just like we do in masjid or in a mosque. It's just like people do in a mosque. So that's how I always say that the histogram is a Muslim graph, and that all of these are actually saying prayers. So this is the main difference between histogram and a bar chart. I'm gonna go back to my presentation. As now, this is also a histogram, but it's they have basically outlined all of the tops and they have removed the bars, and this is just a modified version of histogram. Now, what is a standard deviation? This is a very important concept, and you need to get this right. Your data would always be varied, as you can see in this histogram as well. Data is not concentrated at a single place; it's varied, right? It is this is the mean, this is the median. The mean would be somewhere in between, and this is also the mode because it's the most common value. So after you have seen the graph, the data that is varied from -2 to +2, that is the data or the values that would include 95% of your data is known as your 95% confidence interval, which I have shown right here. Yes. 95% confidence interval would always mean that 95% of data is included in your you can say the range that you have selected. Now, what's the standard deviation? Standard deviation, noted as SD, is just a way of objectifying or of putting the variance of your data in a quantitative form, and it's gonna basically tell you that how much your data is spread out. Okay, so the spreading of the data would mean that if the standard deviation is high or if it's big, then your graph would be stretched out. For example, this graph has a bigger standard deviation as compared to this one. As you can see, this graph is less spread out as compared to this one. So that's all the standard deviation would say. And from your mean, the mean is 0 right here. And in this case, the mean is at the middle of this red graph. From the mean, 68% of data is considered in one standard deviation. One standard deviation is on either side. Because look, the data is going to be lower than the mean, it's going to be higher than the mean. Data mean के दोनों साइड पे होता है. ये बात तो पता है ना. मीन बिल्कुल सेंटर में होता है, तो उसके राइट लेफ्ट दोनों जगह डेटा होगा. So one standard deviation would be from this point right here, -1, all the way to the mean, and then from mean to the +1. This would be one standard deviation, plus minus one standard deviation. And this SD would have 68% of data, and we use 68% data because the standard deviation is on both sides. So the thing plus minus would actually show that from the mean you're gonna go up and you're gonna also gonna go down. ऊपर नीचे दोनों जगह जाना है, दाएं बाएं दोनों जगह जाना है. मीन बीच से आपने दोनों साइड पे जाना है, तो एक स्टैंडर्ड डिवीएशन जो यहाँ राइट पे आ रही है वही आपके लेफ्ट पर भी आएगी. तो जब आप बताओगे ना +-1, when you write it +-1, this includes that this whole reason thing would contain 68% of data. Now the thing is कि आपने रिसर्च में 95% कॉन्फिडेंस इंटरवल रखना होता है. So अब तो ये तो 68 है, तो how you're gonna increase it? You're gonna multiply the standard deviation by 2. अब देखो जो डेटा है वो थोड़ा आहिस्ता आहिस्ता कम हो रहा है. As you can see, the curve is going towards the down side. It's gonna go towards the lower portion. मीन के गिर्द सबसे ज्यादा डेटा फंसा हुआ होता है. And as you go away from mean, the data is gonna spread out. Data आहिस्ता आहिस्ता कम होता रहता है. So in two standard deviations, you're gonna have 95% confidence interval. And in two standard deviation from -2 to +2, you will have your 95% CI, also known as confidence interval. Similarly, in this graph, इन्होंने also show किया हुआ है that the red portion is one standard deviation, the pink portion is two standard deviation, and the yellow portion is 3. We consider just two standard deviation in research. 3 वाली जो चीज है, it comes in very complex researches. You don't have to do that. So ये important चीज है. Okay. And then last चीज जो मैं बताना चाहता हूँ, that's your अपना हाँ normal versus non-normal data. As you can see, यहाँ पे this is a bell-shaped curve. Mean is in the center. Similarly, so is this one. But in this data, mean is not in the center. Mean is slightly towards the left side. As you can see, data is skewed towards the left side. Similarly, the and data in this one is skewed towards the right side. So wherever is the tail, you're gonna say that's the skewness. This in this particular graph, the tail is towards the right side. So right would mean positive skew, and if the tail is left side, left would mean negative skew. Always consider the right side is good side, and that the right side is a positive side. So you have the tail towards the right, and you have positive skew. Okay. Now, after I have basically confirmed all of this, I'm just gonna go towards the SPSS, and I'm gonna show you guys each and everything. Here, in the descriptors, we have the mean, we have the 95% confidence interval right here. Then we have the standard deviation. And then we also would have the median. Median is used in non-normal data. Okay, I'll explain when to use the median. Right now, just consider on mean, confidence interval, the standard deviation, and we also have the range. We have the minimum and maximum as well. Okay. Now, same for this variable as well. Normality. Now, what's normality? I showed you that the data at the center is normal. The data at the left and right is non-normal. Okay. Now, what's the how to see if the data is normal or not? For example, if you can see this right here, to some people this would be normal, to some it would not be normal. Okay. And this one, This would be normal to most, but some people may say this is not normal, because as you can see that if we draw a graph right here, it's going to go up. This is the center point, and then it's going to go down very steeply. So some people may consider that this whole area makes it non-normal. So we need to have a test. We need to have a standardized way of saying if the data is normal or not. And for that, we have uh, the Shapiro-Wilk test, which is most commonly used, or we also have the KS test, also known as Kolmogorov-Smirnov test. But let's just use the Shapiro-Wilk or the SW test. The names are a bit difficult to pronounce, so people have just used abbreviations. Now, if we consider the SW test, you can see that the number of toys have a p-value of minus 0 of less than 0.000, which means it is significant. Whereas the days to fail has 0.339, which means it's not significant. Significance is at 0.05 value, which I may have shown right here. As you can see, the p-value is at 0.05. A p-value is less than 0.05% would show that your study results are good. Above 0.05% would show that your results are bad. Like the lower the p-value, the better the research. That's the main thing. The thing that you have to basically know is this. Okay, the p-value is basically um, it's a measure of the error in your research. So you want your research to have the least possible error and hence least possible p-value. Anyways, so by looking at the histogram, we can say that it's non-normal, and by looking at this value, we can also say that it's not normally distributed. So if you're reporting this data, which is non-normal data, you're going to report the median. And then you're going to use interquartile range, this thing, instead of the standard deviation. Okay. You're going to report 5.00 plus minus 4. Okay. And for the days to fail, which is a normal data, you're going to report the mean, which is 8.98 plus minus 4.19, the standard deviation. Always report standard deviation with mean, and always report interquartile range with the median. Okay, so once you have considered this, I hope that it was basically not any confusing to you guys, because these are the basics. These are not that much difficult. And if you have been following me along this, you would have gotten a good idea. Now, this is a QQ plot. A QQ plot is not necessary for you to learn. I'm just going to tell you that if the dots follow this line, then it's normal, otherwise it's not. And you can see that dots do not follow the line. So this is non-normal. Similarly, same thing here. You can see that it's making a whole upside down mountain, or it's making a funnel. So the data is not normally distributed. A stem and leaf, this is the stem and leaf graph. A stem and leaf graph should always be in the middle. This line should be here at 10. This line should have been here at 5, and this black line should have been at 7.5. Now it's not, so means that the data is not normally distributed. Now we have the normally distributed variable days to fail, and if you can see, the dots follow the line up until just the end. Just this one, this area is not normal, otherwise all of this is normal, so we're going to consider it normal. If you can see this, the dots are near to the point line, except for, once again, the last 4 entries, which would be right here. Okay. And if you see the stem and leaf, it's once again not properly distributed in the center, but it's still better than this one. Like if you consider this, and if you consider this, you'll see a visible difference. This line should have been a light here, and this line should have been right here. But then again, data can never be perfect. Okay. After having all of this, you are done with the descriptive analysis, and now we're going to go to the inferential statistics. Now, for inferential statistics, I would want to say that if you're doing the analysis of two categorical variables, you would need to do a chi-square or a Fisher exact test. Fisher is used when the sample is less than 20. Otherwise, we use only chi-square test. I'm going to now show you how to perform the chi-square. Okay. Analyze, go to analyze, then go to descriptive stats, and afterwards go to crosstabs. Now, rows are always for independent variable. Independent means the variable which is your which does not depend on anything. The variable which is not which is the intrinsic quality of the sample, right? And the dependent variable would go in the column. It would depend. The dependent variable would always depend on the independent variable. Now, the size of the dog is not dependent on anything. It's actually dependent on the dog itself. So we're gonna move it to the row, and now we're gonna click on toy chosen and move it to the column. We're just gonna see if the size of dog has any particular difference on the uh, toy that they choose as their toy of choice. You're gonna go to exact, and the main thing that you're gonna do is you're gonna click on asymptotic only. I'm not gonna explain all of this because it's gonna take extra time, but just click on asymptotic only. Click continue, go to stats, click on chi-square. Now, if you're just gonna do a chi-square, that's enough. But some people, and including me, would always do Fies and Kramer's V as well. Some people do Kendall's toys too, but I wouldn't recommend. Just do Fies and Kramer's V. Now, if the both of variables were ordinal, we would be have to do this candle stop. But since one variable is nominal, we do not have to do this. We're just going to click on files and Kramer's view. We're going to do on continue. In cells, you need to click on observed, and that's it. Don't click on expected or hide small count. It's not necessary. You're not going to do anything in format. Neither are you going to do anything in style. And the bootstrap is used for Fisher's exact test. We're not going to, if you click on this perform bootstrap, it's going to do the Fisher exact test. We're not going to do any bootstrap, so continue. The main thing is you're going to click on display clustered bar chart and you're going to click on OK. First of all, once again, they're going to show you the number of cases. There were 50. There were no missing cases, so it's just going to go show you 50. Then it's gonna tell you the dog toys, X toys chosen cross tabulation, which is the chi-square test. Okay, and it's gonna present the variable which was independent on the rows and dependent on the columns. If you can see that there were the large dogs preferred hedgehog and lamb chop, the medium dogs preferred duck and hedgehog, and the small dogs preferred lamb chop and duck. If you can, I don't know if you can make out, but from my perspective, I can't see a clear, distinctive pattern here. I mean, the data is distributed all over the table, you see, and that is why the chi-square value is less than 0.05. It's 0.225. 0.225 would actually show that the data is not significant, and there is no specific statistical relation between the size of dog and the toy that they choose. Moreover, you can also see the bar chart. Now, the bar chart would give you a very good idea of the data. As you can see that the large dogs do not have a particular choice of toy. They just choose what's in front of them usually. The medium dogs do not particularly like lamb chop, but they do like the hedgehog and duck. So you can explain the data in this regard, but you're going to also mention that it's not statistically significant. If it's statistically significant, you can draw a conclusion from it. You can say that, yes, we can certainly say medium dogs do not like lamb chop. But since it's not significant, you can't say it with certainty. You have to mention that the data was not significant. Now, the small dogs did not particularly like hedgehogs for whatever reason, and then you're gonna just explain the data. For the sake of simplicity, I'm just gonna do another. For in this time, let's just do it with the breed of the dog. Now, the dog's breed is also a nominal variable. Now, both of these are nominal, right? And so it becomes must for you to do a Fies and Kramer V. What Fies and Kramer V would do, as you can see right here, it's gonna show you that the it's gonna like look, a chi-square is not that much sensitive test, right? So if a chi-square is significant and the Fies and Kramer V is not significant, it's gonna tell you that the data is very, very mildly significant and that your conclusion is not robust. However, if you can see that the Fies and Kramer's V is also significant, then you can say with a certainty that your conclusion is robust. Okay, so you can see that say that normal chi-square is this one, and the Fies and Kramer's V is just a more refined version of chi-square. Okay, you're just gonna click on OK again, and now look. Once again, 50 people, 50 dogs were in our sample. And from the dog breed's perspective, I can see that hedgehog is particularly common in Chihuahua. And the fuzzy dogs do not like hedgehog, but they do like duck and lamb chop. And the retriever have, just like the large dogs, they have just a normal distribution. And once again, if you see the value, it's not significant. If you can see the Fire's value and the Kramer's value, it's also non-significant. And the graph also shows you that the data is distributed all over the dogs, right? So this is how you're gonna make you're gonna perform a chi-square, and you're just gonna, as you can see, this is how we perform the cross tabulation. If you can see this table right here, this table is similar to this one. Okay, this is what we have done till now, and now we're just gonna go towards the final phase of our presentation. For the quantitative data, there are two types of analysis that you can perform. There's the normal data and then the non-normal data. For normal data, you're going to do parametric tests, which include the t-test and ANOVA. For non-normal data, you're obviously going to do the non-parametric test. First of all, if you're going to do the parametric test, you're going to go analyze, compare means, and then you're going to click on independent samples t-test. The test variables would be the continuous variable, and then the continuous variable in our case was the days to fail, which was the normally distributed. And now the days to fail, we're going to compare it with the size of the dog. It's going to compare the size of the dog. And now we're going to click on define groups. The thing about define groups is that you're going to have to make groups of these dog size, right? Right now, there are no values assigned. If you can see, there are no values assigned. Now, how you're going to assign values, you're going to click on analyze. You're going to click on automatic recode. Oh, sorry, you're going to click on transform. You're going to click on automatic recode. You're going to perform drag this variable to right here. You're going to click on size underscore of underscore dog. The thing about SPSS is you cannot add spaces between the words, so that's why you're going to add the underscore. I'm going to click on add new name. I'm going to click on lowest value, and then I'm going to click on OK. And what it's going to do is going to perform the values. It's going to give values to all of these variables. As you can see, large is 1, medium is 2, small is 3. Now, the reason it gave these value is because large is the biggest. So it should be given one end of the spectrum, and small is the smallest and should be give the other end of the spectrum. Whereas the medium would be in the middle, which would be 2. And then right now you can see that all these have values right here. Okay. You're going to go to analyze, you're going to go compare means, independent sample t-test. And now we have to, as you can see, that t-test is performed between two groups. If I didn't mention it, I'm going to mention it now. T-test is performed between two groups, okay? ANOVA is performed between more than two groups. So right now we have more than two groups. If you want to compare all of these three groups, we have to use ANOVA. But for the sake of simplicity, I'm first of all going to perform a t-test. And I'm going to perform it between the large and the small. That is the 1 and the 3 group. Okay. We're going to move it right here. We're going to click the size of dog, move it here. We're going to click on define groups. The group 1 would be 1, which is large. Group 2 would be 3, which is small. Click on continue. We're going to click on option. We're just going to see if the confidence interval is 95. We're just going to click on continue. And you're not going to bootstrap at all. Like bootstrapping is only for Fisher exact test. Okay. After doing this, we're going to click on OK. Now, if you click OK, you're going to see that there were 14 in large, 16 in small. Okay, 14 dogs in large, 16 in the small. And the mean for the dog was 6.57. The mean for small was 5.63. Moreover, the standard deviation was 3.7 and 3.5. So the means are fairly, equal to one another. It's just a difference of 1 day. Which is not big of a difference. And now if we go, of course, you're just going to you're going to assume equal variance for now, for the sake of simplicity. You're going to assume that equal variances. And if you see the significance, right here, you can see it's 0.487. 0.487 would show that the data is not significant, that there is no relation between the size of dog and the days it will take them to destroy their toys, right? You do not have to report mean difference. You don't have to report this and this, anything. You just have to report the 95% confidence interval. You have to report the significance value. You don't have to report the TF or the degrees of freedom. Just focus on this. These both report this. That's it. A standard error of mean is only used in very large sample size study, not here. If you have an epidemiological study with a sample of thousands, then people would report standard error of mean instead of the standard deviation. Okay, this is how we perform a t-test. And ANOVA is also performed in a similar manner. Analyze compared means, go to one-way ANOVA. Now we're gonna click on the number of toys as a dependent list. Oh, sorry, the days to fail as a dependent list, and we're gonna click on size of dog as a factor. As you can see, there is no option to define groups. Why? Because ANOVA is used if you have more than two groups, so it doesn't matter if you have 4, 5, 6, 10 groups. It's just gonna perform the test. Okay. And if you go to contrast, you can click on polynomial, but I wouldn't recommend it. Once again, if you want to perform the post hoc analysis is a complex form of analysis used in epidemiological studies. We're not going to do it here. And we're also not going to click. If you want to click on descriptives and means plot, is up to you, but it's not necessary. Some people would also click on homogeneity of variance test. Okay, click on continue, click on OK. Now it's going to perform the ANOVA, and it's going to show you that, first of all, this is a descriptive. It's going to show you that the large group has a mean of 11.79, the median has a mean of 9.45, and the small has a mean of 5.94. Moreover, it's also going to show you all of these standard deviations and the 95% confidence interval for the means and each and everything. Like you can see, it's going to give you all the descriptives. When this is a test for homogeneity of variances, as you can see that most of them, based on the mean, it's not homogeneous. So this means that the data is a bit varied, but not much. Then this is the ANOVA. And if you can see that the significance is minus 0.00, this shows that the test is significant. Okay. P-value is less than 0.05. And this is the means plot. This will show that the means of the mean of large dogs is uh, towards the 11 point, how much? 11.8. It's 11.8. The means of the medium dog is 9.45, and the mean of the small dogs is almost 6. Now, you will say that we saw in t-test, it was non-significant, but now in ANOVA it's significant. How did this occur? The reason it occurred is because we performed the correct test for the correct data. It's very, very important that you perform the correct test for the correct data. If we perform t-test on a data like this, which is meant for ANOVA, it's not going to give us a good value. The results would be distorted, just like they were. But if we perform ANOVA for data that is meant to be performed ANOVA, then we're gonna get the good results. Okay. If we perform ANOVA on a data which has only two groups, the results would be different. They would be distorted, and you cannot report those results. Okay. So this is how we perform the test ANOVA. Of course, in each and every test, you're just gonna say, for example, I'm for this particular example, I'm gonna write that the number of days to fail was significantly associated with the size of the dog. And then I'm gonna report the p-value here. And then I'm gonna say with the large dogs taking the longest to fail a toy and the small dogs taking the least amount of time. And then I'm gonna report the mean for large dog was 11.79 plus minus 2.8, and the mean for small dogs was 5.94 plus minus 2.69. Usually in ANOVA, we report the maximum and the minimum, but if you want, you can also report, um, you know, you can report all of the data, you can report the medium as well, but then again, it becomes wordy. And to be very honest, if you have a good research, you're gonna have so many things to report that you're not gonna be able to, um, explain each and everything. Anyway, after the ANOVA, I'm gonna tell you how to perform the non-parametric test. The data that for the data that was non-normal. Okay. Uh, the non-normal test is Mann-Whitney U test for two groups, and it's the Kruskal-Willis test for more than two groups. We're gonna go to once again, as you can see that this data, um, toys owned was the data which was non-normal. We're going to go to analyze. And now we're going to go to non-parametric testing. This is the most important thing. You have to remember to go to non-parametric test. If you go to compare means, you're going to destroy your whole study. You're going to basically destroy your results. Go to non-parametric test. Go to independent samples, go to fields, and now you're gonna drag this number of toys to the test field. And let's just say we're gonna compare it with the dog size, and we're gonna take it right here. Okay. Now there are no option that you need to set here. You're just gonna click on run, and it's gonna give you a value. As you can see, the value is 0.702, which means that the data is not significantly associated. There is no association between the number of toys owned and the size of the dog. Now, one more important thing that you must keep in your mind, it's that this performed a cross-call Wallace test. The reason it performed a cross-call Wallace test is because um, there were more than two, you know, groups. If there were two groups, it would automatically perform a Mann-Whitney U test. And you do not have to specify it, just like you have specified t-test and ANOVA. You don't need to specify it. Okay, it's automatically going to see the data and perform the respective test. Now if you see the graph, you can see that the large have the highest number of toys owned at 10, but their data is very varied as compared to the medium and small. Like you cannot say that the large dogs have the large number of toys, or the large dogs have a higher number of days, have a higher number of toys, because there are some dogs who have only 5 toys, and then there are some who have 10. Similarly, in the medium dogs, you have some who have 4, some who have 6. In the small, you have some who have 3 and some who have 7. So if the large dogs has had the minimum number of toys that a large dog had were 6 or 7, data would have been significant, and we would have gotten a result. But in this case, we do not, right? That's how we basically, perform the result. Moreover, you can also see that they performed other, or they created other charts as well. You do not need to report any of this. All, if you wanna present, you're gonna just present this graph, and you're just gonna present this data. Okay, do not copy the date table from SPSS. I would always recommend making tables on Word and just using the SPSS to write up the data. Let's perform once more, and this time let us change the variable, and I'm gonna remove dog size, and I'm just gonna add dog breed. Okay, click run. Once again, it's not significant. As you can see, 0.576, it's not significant. And as you can see, Dada Chihuahua, although they have low number of toys, but similarly Retriever, both of them have low number of toys, but still it's not very low as compared to fuzzy dog. Like only a few fuzzy dog have 10 toys. There are also fuzzy dogs with 5, 4, or 6 toys. So we cannot make a proper association. And once again, this is the bar chart. Anyways, this I think ends our presentation right here. Also, if you wanna compare two continuous variables, like how do you compare two continuous variables? You're gonna compare them using a correlation. You're gonna go to correlate, and you're gonna go to bivariate. Now, the problem with a correlation is that you need to have both of these variables to be normally distributed. As you can see, we have only one variable that is normal, the other is non-normal. We cannot perform a correlation. But for the sake of simplicity, let's say both of these were normal. We're gonna add both of them to variable. We're gonna click on mean and standard deviation. We can also click on covariances, but it's not necessary. Nothing in style, nothing in bootstrap. We're gonna click on two tail. We're gonna click on flat significant correlation. We're gonna click on Pearson. The difference between Pearson, Kendall-Torrance, Spearman is that Pearson is used for simple linear correlations. When we are seeing a simple linear graph, whereas Kendall-Torrance, Spearman are complex and they are used for exponential. So after we've added both of these two variables, we're going to click on OK. It's going to draw a correlation for us. Okay. Now the correlation is not significant, as we can see by the value. It's 0.327. If it was less than 0.05, we would say it's significant. Okay. Moreover, oh, so sorry, it's actually significant, minus 0.021. If you can see the significant, it's minus 0. It's 0.00221. So it's significant. and that the Pearson's correlation coefficient, which is 0.327, is basically means that the R value is 0.327. Let me show you right here. The R value. Okay, so it will give you an R value. Okay, R value. R is the coefficient for Pearson's correlation, and R value would be how much both of the variables change with each other. For example, R would show the higher the R value, the stronger would be the correlation. The lower the R value, the weaker would be the correlation. If you're going to go to analyze, we're just going to make a scatter plot. Usually we make a scatter plot and it's made in Excel actually. If I go to this, and I click on this and I click on this, I'm going to go to insert. I'm going to click on recommended charts. There we go. This is a scatter chart. This is how we see a scatter chart. I'm just gonna basically try if we could change the colors of both of these. Yeah, let me just change the color for these. Yeah, as you can see, it's creating the different color. It would basically tell us that this is how data is scattered in both of these, variables. It would basically take the toys owned on the y-axis, and it will take the days to fail on the x-axis. It's going to show us how the data is varied. As you can see, we can see that the number of increase in the number of toys would lead to a slight increase in the days to fail. And if I click on this, let me click on the data. Yeah, if I click on the line and I add a solid line, it will, okay, the line is not showing right now. Let me, now it's showing line for both of the variables. Yeah, as you can see, it's showing a line from this variable to this variable. As you can see, it's slightly increasing, right? For example, if I click from here and I select a line from right here, you can see that it's showing increased in, the variable. It's showing us day by day. It's going and slight increase. It's going from right here to here to here to here to here to here, and so this increase would show that as those are increased as the number of toys are increased, the days to fail are also increased. And that is what it's showing us right here. It shows that 0.327 value would show that a 32% change or a 32% increase is seen in when we are correlating both of these together. Okay. Now the significance is 0.021, and this is how you perform a correlation. But now how you're gonna like mention it, you're just gonna put the scattered plot in, and you're just gonna say that both of these variables, that the number of toys owned were significantly correlated with the days to fail, and that it was at p-value 0.021 with the correlational value or R of 0.327. And you're just gonna enter the scatter plot, and that's it. And now the R is in a positive point, so this means a positive correlation. Let me show you an example of a good positive correlation online. This is a scatter plot, and this is a positive correlation. This is a scatter plot, and this is a negative correlation. And this means no correlation. Okay. This is a perfect positive correlation with an R of +1. Our R was 0.327. It was not perfect, but it was moderate correlation. As you can see, this is a good positive correlation. This R would be around 0.6. This one would be around 0.6 or 0.5 as well. This would be around 0.8, and this would be around 0.9. See, 0.94. So this is how we basically make scatter plots and correlation. Okay. Now, I think each and everything is done. I don't remember having anything else, but the thing that I would recommend you to do is, first of all, obviously, if you want to connect with me, you can connect on LinkedIn via this, and you can also connect on Instagram with me. But if you're gonna connect on, if you wanna take just one thing from this whole webinar, na, I would recommend you to watch these playlists. Uh, I tried my best to show you the basics of data analysis, but if you want to learn it at the comfort of your own home without a person speaking in your mind constantly for an hour at the time of your own choice, you can use these three playlists. This playlist is by Research by Design. He is a professor of statistics. Dr. Todd Grande is a professor of psychology and statistics. Dr. Todd Grande has very advanced analysis. Research by Design. This person, Dr. Todd, I forgot his exact name. He's also Dr. Todd. Both of these are Dr. Todds, but different Todd, of course. This one has done a very simple analysis, and I have also not made videos myself, but considered and found videos online which I found were very easy and which were the videos that helped me. I compiled them into a single playlist and just named it as the basics of research. All you have to do is you have to search this basics of research Faidan Shahzad, and it's gonna pop up, and that's it. Okay, now this would mark the end of my presentation. Thank you so much, and I will now be taking questions.
Assalamu alaikum. I'm Bisma Tahir, the sub-publication section in charge here at MS. I'd like to thank everyone for joining this session first of all, and now as we're moving on to the question answer part of the session, feel free to drop all your queries in the chat box and I'll make sure that all of them are answered. Thank you. Okay, so the first question that we have is that is the Fisher's exact test also for categorical variables?
Yes, Fisher's exact test is used when you're comparing both of the categorical variables with themselves. Next question.
We're still waiting for some more questions as everyone types in.
Okay.
Okay, so the second question we have is that can we do post HUC in Kruscal Willis?
Post hoc test in Cruscal Wallace is not usually done. And I don't think there's an option to do it in SPSS. There may be an option to do it in Strata, but SPSS does not give this option.
Okay, we just got another question that if our data is not normal, is there any way to make it seem normal?
Yes, we can, as a matter of fact, make it normal, but it's actually a really complex thing. So, which is why I've not covered it in this webinar. I'll be sure to cover it in the subsequent webinars, or perform it in another webinar. If you want, I can do it right now.
Okay, Faizan bhai, could you explain up a bit more about converting data into normal?
Okay, just give me a minute. Let me have some water. I'll be sure to, uh, you know, do it. Just give me 1 or 2 minutes. Okay.
Yeah, sure, take your time.
अच्छा, okay, so I am back. मैं audible हूँ और screen share हो रही है ना?
Yes, you're audible and your screen is also visible.
ठीक है। अच्छा, हमारा जो वेरिएबल जो नॉन नॉर्मल था वो आई थिंक नंबर ऑफ डेज वाला था। सो उसको अगर आपने नॉर्मल करना हो ना, we're gonna go to basically उसका ना आपने मीन और वो चाहिए था। You need the mean, you need the standard deviation. We're gonna go to descriptives, basically explore. Let's just go to explore, remove days to fill, click on OK. So what it's gonna do is it's gonna show you the mean 5.96. It's gonna show you the standard deviation 3.36, ठीक है? And it's gonna show you कि आपका data is नॉन सिग्निफिकेंट, ठीक है? जब आपने ये सब कुछ कर लिया है, दिस वुड शो यू कि आपका जो डेटा है वो नॉन सिग्निफिकेंट है। नाउ यू कैन क्लिक ऑन द स्टेप्स फॉर, इसको आपने वो करना हो, क्या नाम है, अपने नॉर्मल कैसे करना है, ट्रांसफॉर्म पे क्लिक करो। ट्रांसफॉर्म में जाने के बाद आपने सबसे पहले जाना होता है रैंक केसेस पे, ठीक है? इसके पीछे साइंस क्या है, इट्स अ बिट डिफिकल्ट है, मैं तुम्हें बैठे एक्सप्लेन करूँ, और कॉम्प्लेक्स है तो मुझे एक्सप्लेन करना भी थोड़ा सा मुश्किल होगा मेरे लिए, एंड इसको सीखने की जरूरत भी नहीं है। ऑनेस्टली स्पीकिंग मैंने भी ये पता है, पहले सीख लिया, फिर मैंने बाद में जाके साइंस सीखी इसके पीछे। मैं कहा यार चलो अब सीख ही लेते हैं, क्या याद रखेंगे ये लोग, स्टैट्स बन ही जाते हैं। एनीवेज, यू गोना गो टू रैंक केसेस, यू गोना remove this variable to from the variables tab to the test variables tab. You're going to click on rank types, you're going to click on fractional rank, important cheese, you're going to click on fractional rank, and then you're not going to click on any ties or anything. And it's up to you if you want to say rank on, click on summary tables. I usually do. Then I click on OK. And it's gonna, after doing this, it's gonna tell you the fractional rank variable is RFR001. Okay, this variable is actually very important. You have to, it's gonna basically, create a new variable, fractional rank RFR001, and you're gonna use this RFR001 for your, subsequent steps for the conversion of the variable. Now what you're going to do is you're going to go to transform, you're going to go on compute variable। देखा इसमें एनालाइज नहीं हो रहा, इसमें आपने सारा compute variable करो, इसको यहाँ पे लेके आओ यार। Anyways, you're going to go to बल्कि actually let me remove this zoom वाला, हाँ ठीक है, zoom वाला side पे हो गया। I'm going to click on this and I'm going to click on the target variable, I'm going to name it, I'm going to say toys underscore normal। okay, ये पूरा हमारा हो गया। Then I'm gonna go to this numeric expression, and you can also find these expressions from here, the function group, and I'm gonna click on idf dot normal. This is the command for the function. If you can't remember it, you're gonna go to here, inverse df, and you're gonna go to inverse df dot normal. This one right here. Okay, this one right here. This is the idf normal. Anyways, after you have clicked on idf normal, what you're gonna do is you're gonna go right here and you're gonna enter a bracket. Wait, let me click here and enter a bracket. And you're gonna click on this one. It's gonna add the name. Okay. After the addition of the name, you're gonna click on comma. You're gonna click on the mean, which was right here. Let me show. The reason I've kept this at the corner is so that we can see the mean simultaneously. 5.96. Then we're going to click on comma and we're going to click on the standard deviation 3.368. Okay. After you have done all of this, make sure that you are not adding any space between all of these. If you add any space, like I said, the SPSS is going to consider it as a separate thing, and it's going to give you an error. I've had way many problems with SPSS doing this, honestly speaking. So anyways, once you do this, I'm gonna click OK. See, it has made a new variable. If you go to the variable tab, toys normal is now made. And if you go to analyze, descriptives, explore, I'm gonna click on toys normal, click OK. See, the distribution is fairly, bell-shaped. It goes from here, then it goes here, here, and then it goes here. If you see the value of Chaparral is 0.408, The 0.408 would basically show us that the data is normally distributed. Moreover, if you go to the QQ plot, you can see it's almost towards the line, but just except for the last part, except for this one part, it's normally distributed. The if you want to go to detrended QQ plots, you can also see that it's fairly normal except the last two entries. And if you see the stem and leaf, you can see it's almost normal. If we make this line a bit higher, it's going to be perfectly normal data. And now, if you want to perform a Pearson correlation for correctly, I think we should perform it now with analyze correlation. Bivariate. Bivariate basically means if you're using two variables. Now we're using two variables, so we're going to perform a bivariate correlation. We'll click on OK. And right now, the value is still 0.014, which means it is significant. And the Pearson value has actually increased to 0.345, which means that the R value is 0.345 and it's mildly significant. Anyways, next question.
Okay, thank you for that
Also, if there's
explanation. Yeah, sure.
also if there's any questions between this, if there's any question regarding how I converted it to non-normal, if they're from non-normal to normal data, be sure.
Yeah, we'll keep an eye out for those questions. By the way, we had another question. How can we use data to predict future outcomes and trends?
How can we use?
How can we use data to predict future outcomes and trends?
A prediction model is actually done by using regressional analysis. That's a completely separate realm of analysis. But if you want data to predict trends, etc., I think one way could be doing a pilot study. If you perform a pilot study of, let's say, 20, 25 people, and you analyze the results of the pilot study, you're going to have an idea of what type of population you're dealing with. This is especially common in cross-sectional studies when we are like sending the survey to a thousands or 1,500 people, and there's always going to be people who are going to fill the form by making patterns. They're going to make the zigzag pattern. So if you send a pilot study and you see that the results from a particular medical college are very bad. This shows that the students in that medical college or the particular cohort of the medical college that you sent that form to is not filling it seriously. So you should not send your form of the original study to there. That's why we do a pilot study. So you can do that for sort of a so-called prediction. But if you really want to predict something, or if you really want to predict models, that's regression analysis.
Okay, thank you. Another question was, is there a way to select specific cases from entire data?
Um, Doing so in SPSS is very tedious and hard work. I would personally say if you want to do it from Excel, you can control, hold control, and let's say I want to select every fifth participant that I see. I'm going to click on this. Then I'm holding control with my left hand, and I'm clicking on every fifth participant with my right hand. So you can see a control of these. Then you're gonna click on Control C. If it's not Control C, then you can see on click Control X. It's up to you. You're gonna click on plus. You're gonna paste here. Oh, sorry. You can also click on hold control, and you can select it like this. See, I'm selecting it manually because Excel is giving me an error, and I am holding control because obviously it's come on. Yeah. See, that's how you can basically uh, put take out certain cases from your study. But the one thing that I would personally recommend is, why do you even want to take out these cases from your study? Like, that doesn't make any sense now. Anyways, next question.
We're just waiting to see if there are any more questions left.
Okay.
Okay, I don't think we have any more questions. I think this concludes our part of question answer session.
Chris, and anyway, if there are any other questions that you receive after the have ended this webinar, be sure to send me on WhatsApp. I'll be sure to answer them to the best of my ability. Moreover, I would also like to thank all of you for coming and attending this webinar. I hope you gained knowledge, and I also hope that you would be able to perform the basic analysis now. I hope my point was also conveyable to all of the students who listened. And lastly, a very massive thanks to the Haris and all of the team of the organizers for organizing this workshop and inviting me as a speaker. It was an honor for me. Thank you so much, and Allah Hafiz.
Thank you, Faizan Bhai. It was a fun workshop, and we are very grateful for your time and, of course, enlightening us with this knowledge. And we will be sure to bring you back to our channel from time to time so that our audience can experience such highly valuable content. And I would also like to extend my gratitude to our organizing team for a great workshop indeed, and our audience for such a positive response. And stay tuned to our channel for next workshop. And thank you all for joining us today. Assalamu alaikum.